Welcome to this episode of Little Shop Live. We're going to be talking about energy today. So I'm here in the studio with Rebecca and Emma and Ty, and we're going to do a whole bunch of things with energy. And we have some special guests as well. And Emma is getting tired of holding this thing, and so we're going to jump into this. And Emma's got a whole network of popsicle sticks over there that are all bent. And when they're bent, they store
energy. Lots of energy.
Lots of energy stored.
Right now, I am the one keeping this from absolutely exploding. So as soon as I let go, hopefully these go everywhere. So let's see.
Wow.
I've been waiting for that.
That was awesome. That was awesome. So a lot of stored energy, and it was released. And I think I saw some elastic potential energy turning into kinetic energy as those things went flying through the air. Oh, and heavens to Betsy, over here on the Ty and Bry side of the table, we got a whole bunch of dominoes that we stacked up earlier. And since they're higher up than when they fall, they got some stored gravitational potential energy. And I think, Ty, you need to trigger a reaction here. We got a little chain reaction going on. And another energy release, which is fantastic. And we do have special guests today. We have a couple people we want to recognize. But first, we're over to Debbie Holman's class at Wellington Middle School. Oh my gosh, I thought we had big dominoes. These ones are even bigger. These are awesome. So let's do one more domino. Oh, no, kids are going crazy first because they're seeing themselves on camera. They're excited. Everybody do anything you want to do on, well, not anything you want to do on camera, but, oh, wait, hang on. We got the dominoes coming. Here it goes. Should we have a countdown? 5, 4, 3, 2, 1, go. And
wow.
Kaboom! That last one is awesome. That was an awesome, awesome domino. And we have done the whole chain before, which is kind of dramatic and kind of awesome. I want to do a special shout out to another group that's visiting today, which is May Yazzi's class down at the Southern Ute Academy in Ignacio, Colorado. So special shout out to you folks. Thank you so much for being on the Zoom. And if you want to be on future Zooms, you let us know and we'll ship some materials your way. And the teachers who have gotten materials from us, we will have a spot to use that in about 10 minutes or so. We're going to give time for people to play with some of the energy toys which we put in your kits. But today we're going to start by talking about energy by looking at energy transformations, and Emma has made us a whole bunch of slingshots. Emma, tell us about the slingshots. How are these made?
These I made super easily. I used 2 pencils, a bunch of rubber bands, which is why we get that stored elastic potential energy, a bottle cap, and an eraser just to separate the 2 pencils. And as you can see, it makes a pretty effective slingshot. We all have some Orbeez.
Oh my gosh, oh my gosh.
I'm aiming for Brian right now.
I better get ready. I was not set up here. Okay, so we're storing elastic potential energy in the rubber band, and it turns into kinetic energy. Ty has got my back. And the Orbeez slingshot looks fantastic. And it turns out the amount of energy we store in these bands is about as much as it takes to launch an Orbeez at a pretty good
It literally almost hit you in the head.
One more. Okay, bring it.
Get like a bunch at once.
How'd you get yourself?
Oh, so we stored some elastic potential energy in that stretched rubber band. And Ty, you have a device. This is the Timbird, which we've seen on a previous episode. And this one, how do you put energy in this?
So you twist it up and you just tighten up the rubber band.
Tighten up the rubber band. So you're storing some elastic potential energy.
I sure am.
Ooh, and crank that thing. We want this bird to fly.
I'm going to give it a couple more twists. And then I'm going to release it, and I'm going to let it go.
Here it goes. Oh!
It almost came to me.
Almost came over. Timbird is migrating to the other side of the studio. That is awesome. So again, we store the energy in those elastic bands. And that's one way you can store energy is with something that you can stretch or you can bend. We have the popsicle sticks. We got the elastic bands for the slingshots and for the Timbird. But you can store energy in other forms, and Ty has got some energy stored in the form of chemicals over there. Let's see what you got.
Okay. So I have a balloon, and I'm going to put a funnel in. And inside this funnel, we're going to add baking soda. And you might ask, how much baking soda?
A lot.
A lot.
I think more chemicals means more energy. And
Absolutely.
I want more energy.
All right.
Awesome.
And then that's going to go in there. And we also have citric acid.
Oh, and citric acid, that's edible, isn't it?
You can eat this, yeah. You can buy it at the grocery store.
You can buy this at the grocery store, but Rebecca, you were saying this is in something?
So some candy. So if you ever had Sour Patch Kids, it is the stuff that is coating the outside of your Sour Patch
Oh, so that's
Kids.
what gives it the sourness.
Yeah. So like that's why they say it's sour, then it's sweet. It's sour because the citric acid is coating the outside.
I see. So citric acid, and we just got a bag at the grocery store, and you can get that. And Ty is going ahead and putting that in the balloon.
Yeah, she's trying.
Oh, yeah, and I think if you shake it up and down, you think it... Or maybe you were right, just the spoon. Are we getting some good chemicals in there?
We were trying.
We need more. Was that balloon already wet?
It was.
That could be what's happening. I wonder if we're...
Goodness.
Let me use my key here.
Okay.
Because this is going to be a good size. There we go. Okay,
that's
chemicals.
perfect.
You get
While
in there.
you guys are getting that ready, do we want to give Rebecca a chance to show off the airplane
Absolutely.
launcher that she made?
Oh, gosh, did I totally forget the airplane
You did, in
launcher? I'm
fact.
sorry. Why are you getting that ready? Emma, show us how the airplane launcher
Or
works.
Rebecca will show you.
So I made this airplane launcher, kind of the same method as the slingshot with the rubber band, and it's going with a stored elastic potential energy.
Uh-huh.
And when I pull it back, I'm gonna launch it at Brian. It's gonna be funny. I have this airplane. When I pull it back, it flies.
Wow.
Yeah,
Awesome.
so kind of cool.
Revenge. I
There we
didn't
go.
do it with the Orby, but I got it
Cool,
with the
similar concept to the slingshot.
Well done, and thank you for calling. And when I forget things, you also go ahead and just call me out on my short-term memory loss. I mean, seriously, that's awesome.
mean, though.
Oh no, it's not mean. Oh, and Ty is now ready.
I am.
We need to take a look at this one here. So we got a balloon with a bunch of chemicals inside, and as they go in the bottle, oh my gosh, I'm having a chemical reaction. And it looks like the energy being released is being used to
blow up the balloon.
Awesome. And what reaction is happening? So citric acid plus sodium bicarbonate, which is baking soda, gives us carbon dioxide.
Carbon dioxide, yes.
Awesome.
Carbon dioxide.
And you know what I want to do with that? Because this balloon is blown up.
Yeah.
So we took the chemical energy and we turned it into elastic potential energy of a stretched balloon. If we took the balloon and let it go,
ooh.
I think we could take that elastic potential energy
a
and
bunch of carbon dioxide in here.
Yes.
That's what we love to breathe.
That's right. That's right. And if we let it go, we got some kinetic energy, and we're sending something back your way. You've been launching things our way. It's our turn. It's our turn. And then Emma's got another version of this.
I've got the Alka-Seltzer Rocket here, which is another version of a chemical reaction. So what I'm doing is I have a water bottle here, which I've made into a fun rocket. And I'm going to do my best not to make a mess here, but I'm just putting some water in there, and this water is warm.
And what does the warm water get you?
The warm water will help speed up the reaction because we're putting some heat into there, some extra energy. And then I have to work as quickly as possible here, not to make a huge mess. Oh boy.
Oh boy, oh boy, oh boy.
Cork it so that all that air gets trapped in there. And then I'm going to put this towel up.
Oh, I can see the bubbles. And so the pressure is increasing. There's energy being stored in the pressure.
I see it moving.
Oh my gosh.
Wow.
That was great. And Emma,
That was
if we didn't do that in the studio contained in the tank, how high would that go?
Oh, it was going at least 20 feet.
20 feet up.
Wow.
So that one, you had some chemical energy, and then it turned into that energy of that compressed air. That's another form of stored energy.
Yeah.
And then it turns into kinetic energy of the rocket. And then that goes into a gravitational potential energy that goes higher and higher and higher.
So
it's
many types of energy.
So many types of energy. That's like your energy thing there. And Rebecca's got another form of stored energy going on over there. Rebecca, tell us what's happening.
So I have this bottle set up that is getting a current from our power supply here, and it is separating the hydrogen and the oxygen, and it is creating these bubbles, and I have a little some bubble solution at the top, and it's actually pumping up hydrogen and oxygen into this bubble, and those are actually both flammable and can be considered fuel. My bubble.
Oh my gosh, well, the hydrogen, I think, is your fuel, right? Because when you burn something, you're going to be combining a fuel with oxygen.
Yes.
So inside that bubble, you've got the hydrogen, you've got your fuel. And when you burn the fuel, actually, let's see if it
works.
Oh!
It pops.
Oh, we need to see another. And I heard a little whoof from that,
Yes.
which was kind of awesome. Let's do that. Let's do that again. And then I think about the energy transformations, because right now you're putting electric energy into the system from the power supply, and it's splitting that water into hydrogen and oxygen, which gives us chemical energy. And let's let it get. Should we let it get bigger?
I
Oh
don't know
yeah.
how big it's going to get on my palm.
Let's give it a little longer. And we can always do another bubble if we have to. Oh, yeah, and Patrick's zooming in on that is awesome. Bubble is there. And that's a bubble full of hydrogen, which is flammable, and oxygen, which is what it combines with when it burns.
Light her up.
I think light it up.
Oh, that one didn't work.
One more.
One more.
And bring that flame in. Bring that flame in quick so that we don't just pop the bubble, but we light the thing up. Okay, so that's a bubble full of hydrogen and oxygen, and
that one worked.
Boom!
That one worked.
Awesome, awesome. And so we're getting that chemical energy. It makes a little sound energy, which is kind of awesome. It's kind of an awesome, awesome thing. Well, that's enough for us, I think. What I want to do now is I want to go over to the classroom. And at Wellington Middle School, we have a bunch of devices that illustrate the principles of energy transformation from one form into another. And Heather is there in the classroom. And Heather's going to lead some students in some exercises with toys and energy. And then folks who have your own toys, you can be doing the same thing.
We're going to pick up the poppers. Does everybody have their poppers? All right, so you're going to get your poppers ready. And tell me, what kind of energy is this starting at? What is this going to? Potentially kinetic. All right, let's fire up. All right. See the poppers? Well, that's awesome. All right, so now we're going to get our pullback racer. So
I mean, look at those poppers go. That is awesome. And so we're storing some energy.
Brian, we got our pullback racers now. We got our pullback racers.
Now the racers. Awesome, awesome. Pulling back, storing some elastic potential energy. Let them go.
Look at that. Love it. Awesome.
We're getting kinetic energy. Those things zipping across the floor. Awesome.
Ready for the flyers?
Oh my gosh. And now it's time for the physics flyers. What?
1.
And look at those things go. That is awesome. And with those ones, it looks like they're putting in some kinetic energy because they're making it move. And then as it goes higher, it's getting some gravitational potential energy. My theory is if I put in more kinetic energy, I should get more potential energy. They should go higher. Should we do one mass launch to the poppers? Can we do that? Or the flyers? One mass launch to the flyers? And a countdown? Everybody get your flyers ready. Okay, 5, 4, 3, 2, 1, launch! Oh, awesome. Shout out to Wellington Middle School and Ms. Holman's class. Thank you so much for joining us today. That was awesome. And then hopefully, folks in your own classrooms, you got those energy toys. You could do them now, you could do them later, but they're all to illustrate some principle of energy transformations from one form to another. There's one form of energy we haven't talked about yet that we want to talk about because it's pretty important. So right here, I've got this steel ball. And it turns out steel on steel is bouncier than you think. If I take this ball and I bounce it, it's got kinetic energy. Then when it compresses, it makes some potential energy, comes back to kinetic, back and forth, and it will keep bouncing for a really long time. But eventually, all that energy, oof, now it's all gone. Now it's all gone. But it can't be gone because we know energy's conserved. Can't create it, can't destroy it.
Right.
So it's got to turn into another form of energy. And what are we missing? What piece of the puzzle?
I don't know, Brian.
I think you do know, Emma, and I think you have to tell me, you rascal.
I think maybe thermal energy.
Thermal energy. It just got slightly warmer. And it just takes a little bit of time for that energy to turn into thermal energy. Because steel is really bouncy. Oh, you know what else is bouncy?
Glass.
Glass. And Ty, you got a device here. And wait a minute, this device is going to have its public debut in 2 weeks, right? Tell us about that.
It's for our Spring Science Extravaganza. It's on April 23rd.
April 23rd?
In the Montfort Quad from 11 to 3.
And we've all built stuff, right?
Absolutely.
So, Rebecca, what have you put together for that?
I have put together a really awesome space called Bubbletopia, where we learn about the physics behind bubbles.
Awesome. And you've got some bubbles going on today, so this is on brand for you, I guess I would say.
I guess I just was thrown into the bubble. I am the bubble person now.
Awesome.
This event is so important. I've recruited my friend all the way from New York, and we are going to be working on big air. So we're going to be launching stuff.
Oh my gosh, so launching stuff, flying stuff, a lot of things with a lot of big air. And Ty, how about you?
Mine has to do with speed.
Ooh, speed. Tell us more.
It's Are You Fast Enough? So we're going to have some running. We're going to have some pulling.
And do you think you're fast enough?
I think I'm fast enough.
But the question is, with all the kids out there, are you fast enough?
Yeah.
That's our question. That's our question. So, and then this is one of the things that Cecilia built this one. And this is like, wait a minute, you have glass balls that are going to slam into each other? Glass is bouncy?
It is bouncy.
Whoa. Well, that is awesome. And that is loud and bouncy and optical and all kinds of awesome. Let's do one more time. Those glass balls, they bounce. It's like those things you see with steel balls, but with glass, which is fantastic. And then eventually all the energy, they're not moving anymore. We lost the kinetic energy. Now it's in the form of thermal energy, all the thermal energy.
I just get an A in physics because of that?
You're going to get an A in physics because you're clever and you work hard. You don't need me to hand you one, you rascal.
Stellar answer.
Now let's go ahead and pull out our putty, and we're going to do a little demonstration with putty here. And the putty that we have is special color changing putty. And what colors does this change? And Rebecca, you've gone into the whole color change. What sequence does it go through?
So it first starts with the dark blue, like you can see in Emma's tin here.
Dark blue putty.
Dark blue. And then it gets to this purple. And then it slowly, or maybe not.
And we have to warm it up.
Oh, yes. We have to warm it up.
And how are we going to warm it up?
I like the.
And when you say warming it up, you're going to put thermal energy into it. Emma's got an interesting technique. Emma, what do you got going on?
I hit it hard enough.
And when you punch it, all the energy of your hand goes into thermal energy in the putty. Emma's getting some frustrations out. Is it warming?
I think so.
Oh, and I'm hitting mine with a hammer.
Brian's got a mallet.
Wow.
Mallet.
Is it warming?
It is.
Oh,
It's changing
goodness.
color a little
I'll
bit.
let Brian have a mallet.
So all the energy of the mallet turns into energy of the putty. There was a question in the show notes that was, could you cook a chicken by slapping it? Answer is,
Yes.
you could.
Technically, yes.
Because the energy in your hand turns into thermal energy of the chicken.
How long would that take, though?
How long would it take? It's going to take a while. But Rebecca, yours is, you're putting energy in by stretching it.
Yes.
Oh, I see. So in that way, you're stretching it, I'm pulling it, I'm doing work on it, I guess we would say in a physics sense. And all that energy is being expressed as...
Here's the cold.
Oh my gosh,
comparison.
look at that.
Wow.
Rebecca, you're working this.
I know. Putting in the work.
And mine, Ty and Brian over here. No, yours is warmer than mine.
You're right.
Like, I'm the slacker over here.
Brian and Emma have cold hands.
Also, I think Old Man Jones is just not able to kind of like put out as much energy output as I used to, apparently. This is
Maybe
awesome.
you haven't put enough energy into your system.
That is a thing. That is a thing that could be an issue.
Man, how did you get yours to do that?
Oh man, Emma's...
Yeah.
Work.
Yeah, but I've just been putting in the work, literally as well as figuratively, which is an awesome, awesome thing. Oh, and speaking of putting in work and thinking about energy, man, I am just not.
No, not at all.
No, look at mine. I get
Are you a vampire?
That's it. That's it. It's the vampire. So Ty has some elastic bands over there, and we use the elastic bands for something real special.
Yes.
And the elastic bands, it turns out when you run, you're moving your legs. When you move your foot forward, it's got kinetic energy. When it stops moving, you lose that energy. And then that energy is basically lost. And then when you move your other foot forward, you gotta put energy in it. So we've got some elastic bands here. Oh yeah, and these are stretchy. We can
They're
store
very
energy and
stretchy.
potential energy.
Yeah.
And Emma, tell us about the little thing we did out on the mud for a quad.
So we had to make this into a video because there's not enough space to do it in here. But we realized that if we put those rubber bands or elastic bands around our ankles, it would make us more efficient at running. And we had Milo as a guest as well.
My
We were
dog
afraid
Milo
we
is
would
there, which
lose
is awesome.
Brian
He's like,
during this video.
what
He
is
just kept
Brian?
running.
What is Brian doing?
Stop.
And
I'm so scared.
and it does make you more efficient. It makes you more awkward. Emma, I like your technique.
Yeah, we get a little waddle in there. But see, look how fast
Absolutely.
I am without the band.
Right.
I'm using too much energy. And Milo, the dog,
Yeah, Milo's like, yeah,
much faster.
much
than me.
I
faster.
wonder how much energy Milo uses.
Oh,
Milo's efficient.
He's more efficient.
Yeah.
I bet I could run farther. than
Oh, you know, it's his teeny little feet. We've got the big feet, which is it kind of like makes us less efficient. That is awesome. He does. He's got teeny little feet.
They smell like Fritos?
They do, but he's running on his toes.
Yeah.
You know this, right? He's basically running on his toes. But wait a minute, we have another thing that we're going to use with a conservation of energy going on here that Rebecca has. And Rebecca, this is a little plunger, and you're going to do work on this plunger like you stretch the putty, but instead of stretching the putty, you're going to compress air. And when you put work into it, you're going to heat up the air, and it heats up enough. Tell us what we're going to see.
So when I push down and I add work into the system, the cotton is heated to a point that is above its ignition rate, and you'll just have to watch and see what happens. Patrick might want to zoom in close to this.
Okay,
Patrick is going in. He's going in. And there's our little piece of cotton. And we're going to set it on fire, not with a match, but with... Oh, my gosh. That was awesome. You made the air, by compressing it, you made it hot enough to actually set that cotton on fire, which is phenomenal, phenomenal. You are definitely putting in the work today.
Am I carrying this episode on my back?
I think we could say that. I think we could say that. Now, Ty and I are going to do a little conservation of energy exercise because that's the next thing we want to look at. And we know energy is conserved. And so Ty is putting energy in this car, and you cranked it 4 times.
4 times.
And then we're going to count how many times it goes around the little container. So we let it go, and it goes around 1, 2, 3, 4, 5, 6, 7. All right. And now I'm going to bring it back and not put in 4, but put in
8.
8. So we're putting in twice as much energy. If it went 7 times on 4 cranks, what do y'all predict?
14. Sorry.
Oh,
I'm
sorry.
sorry.
That was my fault. My bad. My bad. I did not know it was coming.
No, it's all right.
So we're predicting
It was going for
twice as much energy,
Absolutely.
twice as far. So we're saying 14.
Absolutely.
And there was a little Orby in there too. I don't know where that came from. Get out of there, Orby.
All right.
Okay, here we go.
8.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Awesome, awesome.
Great,
And
that's pretty
15,
good.
15 is equal to 14. That's pretty close
Yeah.
for a not so carefully controlled experiment. So putting more energy in means we get more energy out, which is awesome. And speaking of that, we have a generator thing going on the other side of the table. Let's see what Rebecca and Emma have.
So when I turn this and the light isn't turning on, I'm not getting a lot of resistance. I'm not getting any type of...
So you're not having to put much energy in because nothing's coming out.
I'm not putting in the work.
You're not
I'm
putting
going
in
to
the
make her
work.
put in the work.
Oh,
All
yeah.
right.
Oh my gosh. And then all of a sudden, can you feel the difference?
Yeah. It's like
We can hear it too if you
I
listen.
hear it. It's
oh.
And let's get Rebecca going really well, and we'll listen for it. So if we take off the switch. Wow. You can hear it.
absolutely.
You're making her put in the work. You're saying, like, I'm not letting you get away with that, you slacker.
Today.
And then Ty and I have a couple of awesome cars here. And these are little tumble buggies.
Yeah,
And these tumble buggies normally run with batteries, but we took out the batteries.
we sure did.
This is an exercise in sharing. So it turns out that the motors inside here also work as generators. So if I take this car and I push it, it produces electricity. And the electricity is getting sent by a wire over to Ty's vehicle.
What?
Awesome. And then you can give a little energy back.
Oh my
Awesome.
goodness.
We're sharing. We're sharing. This is awesome. And how about if you pull yours backwards? Will mine go backwards? Yeah.
Oh, wow.
So you can go back and forth. And this is just 2 little tumble buggies that we took out the batteries and wired them together. Awesome, awesome energy demonstration. And I see, oh yeah, Rebecca and Emma are pretty excited over there.
We have been waiting for this whole time. We're very excited to show our magic trick. So
awesome.
Can I go for it?
Oh yeah, and tell us what we're going to see.
Big flash of light coming from our hands.
Oh my gosh.
Oh,
wow. That was awesome. And your hands stay cool because...
Yeah, because the water from the heat takes the water from our hands, not our skin.
Oh, awesome. So what's happening is you're producing a lot of thermal energy when you burn that cotton. But what you're doing is it's just evaporating water from your hand, keeping you cool, just like sweating keeps me cool.
I just want to say, Brian has let me use fire 2 shows in a row and 3 times in this episode.
Awesome, awesome.
He trusts me.
I do trust you. And Ty, I think Ty's got to do this one too. So let's do a close-up. And so Ty is trusting me to get this flame near her hand.
I am.
And so I'm going to release a lot of thermal energy. And when we release a lot of thermal energy, what's going to happen is... Wow. It just evaporates the moisture. Now your hands are a little warmer.
No,
and
yeah,
drier.
definitely they are.
Awesome, awesome, awesome.
It smells great.
It
Now,
does.
it turns out you can get, and I think Rebecca alluded to this, if you're using energy, you know where the energy you use comes from. It comes from food. And there is energy in food, and we can demonstrate that really dramatically. And here's a little demonstration we're going to do. So first off, where did my lighter go to?
Right over here.
There it is. Awesome. I'm going to have a little
You put it down
flame
right in
source.
front of him and you lost it.
I did. It's, I've been doing this for a few years. There we go. So you're going to have a flame source, 150, that's what we decided last year. It's a little flame source, and then I have a fuel source, just like for you, it was hydrogen. This is coffee creamer. It turns out coffee creamer has a lot of fat in it, and fat is a really good fuel. And then I'm going to blow some air in there. What it's going to do is it's going to turn this into a little bit of a powder. Oh, yeah, and Patrick is going to dim the lights for us, which I think is kind of awesome. And then if we look at the top here, I'm going to turn it into a powder. And the powder just means that the little particles of creamer can be near the oxygen that they need to burn.
Wow.
We got a little puff of flame from the, oh my gosh, little puff of flame from the creamer, which is kind of awesome.
Yeah.
Cool.
It was hot over here too.
Oh yeah, you get a little thermal energy from that chemical
Yeah, a lot
energy.
of thermal energy.
But it's a similar reaction that happens in your body when you use food. I mean, you take it and you basically oxidize it. You take in carbohydrates, you breathe in oxygen, you breathe out carbon dioxide. That's where our energy comes from. And we want to ask you a couple of questions about that. I'm thinking about energy and food. Suppose I was to eat a large apple. And my question is this: how long would that run my body if I was to eat a large apple? And we are going to put a poll up there. We have a lot of students, and we've been talking a lot. It's time for you all to weigh in. So go to the computer. We'll put up a poll there. If I eat a large apple, how long would it power my body? When you're ready, go ahead and chime in.
Is the Jeopardy music copyrighted?
We can sing it.
Yeah, we sing it.
We can't stop it.
Do 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 do. Do 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 do. Do 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 do. Do 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 do.
Awesome. And the consensus of the group here, more than half of the people, 60% of the people have said 1 hour, and 1 hour is actually about right.
Smarty pantses.
I know. You can't sneak anything past these kids, these little rascals. And so that one is true. 1 apple will power you for about 1 hour. Now, here's another question for you. Right now, even though I'm just pretty much at rest, I'm not doing too much, organs in my body are using energy. Which organ in my body is using the most energy? Your brain, your heart, your kidneys, or your liver?
They get this one right.
I'm going to be impressed.
Extra smart.
I didn't even get it
impressed.
right.
You should be teaching her.
I sure didn't get it right, and I've been doing this for many, many years.
Oh my goodness.
My education revolves around biology of things, and I didn't even get those.
Yeah, this was a surprise to me. And so far, we're getting a lot of people saying your brain, which I wanted it to be my brain.
It's understandable.
I want my brain to be the most energy-intensive organ in my body. Other people said the heart.
I also
That's
want
also
my heart to
understandable.
go.
Yeah.
But you know what nobody picked? your liver. Number one in terms of energy use is the liver, which is kind of awesome and amazing. So shout out to your liver for all the work that it's doing on your behalf. The liver is putting in the work of all the chemistry needed to make your body run.
They're filtering everything.
They are.
All
They
the
are.
time. All the time.
And we got 20 seconds left. I want to do two things. First off, thanks to Mayazi's class down in Southern Utah. That was fantastic to have you here. Thanks to Debbie Holman's class out in Wellington Middle School. Yay for you folks. Thanks to all the Poudre School District teachers who joined us. Thanks to Adam and Patrick for making everything run behind the scenes. Thanks to my compatriots, Rebecca and Emma and Ty. Thank you so much. See us at the Spring Science Extravaganza on April 23rd on the Montfort Quad, and see us back here on April 29th for a show on sound. We'll see you on the next one.